Okay. I think we are ready. All right, so on the 5.3 section, if I can find my, there we go. There it is, somewhere. 5.3, triangle similarity. So this is a little different than congruence because we don't need as many pieces of information for similarity. A little bit, yeah. But you're doing the same thing as far as like finding angles or finding sides. But the sides have to be proportional, okay? It's not congruent sides. The sides have to be proportional, but the angles have to be the same. So the most common one is finding two angles for them to be similar, okay? So angle similarity, if you have two angles in one triangle congruent to two angles of another triangle, then they're similar. Okay. Remember, it's not congruent. Okay, it's similar. They could be different sizes. Okay. Side means all three sides, and you have to check all three sides. Their ratios are all the same. Okay. You set up the proportions, and you divide the ratios, and you make sure that you have the sides that are matching up from one triangle to another. They must match up. And side angle side would be you have sides that match up, and their ratios are the same, and the angle in between them, the angles in between them from one triangle to another are the same. Okay, so as we do some of these, you'll see what we're talking about here. Let's see. Determine if the examples below are similar by angle similarity. So I have a 74-degree angle, a 75-degree angle. Here I have a 75, so I have one that matches up. Can I find out what this angle C is to determine if it matches up with this angle F or E over here? So take out your calculator and subtract 74 and 75 from 180. So you're going to do 180 minus 74 minus 75. What does that give you? You done it yet? Does it give me 31? So on my calculator, 180 minus 74 minus 75 gives me 31. So that angle's 31 degrees. Okay, so do I have two angles matching with two angles of another triangle? Yes. So this is yes by angle. That's what they were trying to prove. Angle similarity. So this is yes. What is the congruency statement that I would write? Triangle. If we say ABC, then we say similar to triangle. So if I go ABC, then I have to go the 75 to the 74. It'd have to be DEF then, wouldn't it? To make sure everything matches up, sides and angles. Example 2. Can we find any other information? All right, we have vertical angles here. This angle would match with this angle, and I'm writing that with 2 marks because the other angle had 1 mark, and I didn't want to indicate that they were all the same. So these 2 are vertical angles, and so that means they're the same. So I have 2 angles, right? So yes, angle similarity. And what is my congruency statement? If I say, I don't know, WVX similar to, then I have to say ZYX. Okay. All right, that's angle. Let's see, next one, side similarity. So here I have sides, but I have to make sure the ratios are the same. So I have to make sure that I have the triangles matched up, the correct side with correct side. So if I don't know, like it doesn't give me a statement. It doesn't say QPR and TSU or whatever. So I look. In the first triangle, the smaller triangle, the smallest side probably would match up with the smallest side of the bigger triangle. So if I say 3 over, what would it be, 6? Does that equal 4 over, next one would be 8, and 5 over 10? Do those all reduce to the same number? Those all reduce to 1/2, don't they? Now, I could have done it the other way. 6 over 3, 8 over 4, and 10 over 5. Those would all have reduced to the same number, right? It depends on which direction I'm comparing them. Am I comparing the smaller one to the bigger one, or the bigger one to the smaller one? In this case, it doesn't really matter because it's not asking me that. Okay, it's just saying, are they similar? And so you just choose which way you want to compare them. Either way, we get the same ratio throughout. And so yes, this one, side, side, side similarity. My statement would be, if I say Q, P, R, then I have to say, what, TSU? Okay. The bottom one. What's the largest? I'll go the left one to the right one, just for kicks. So I'll go largest side compared to the largest side of the other one, which would be, what, 28? Does that equal, next largest would be 32, next largest would be 25, and then what, 30 to 24? So take out your calculator and divide all those. 35 divided by 28, 1.25. 32 divided by 25, 1.28. Okay, so I know right now that they're not similar, right? The ratios aren't the same. Just for kicks, what's the last one? 1.25. So 2 of them are the same, but not all of them, right? So these do not equal. So this is no. The ratios are not the same. Okay, last one here. Example 5 and 6. By side, angle side. So we have to have an angle in between two sides that we need to compare to see if the ratios are the same. When I say ratio, I mean like scale factor. Okay, that's another word that we'll use for that. I have the angle, so 8 would have to be compared to what, 6? And does that equal 20 over 15? If those two ratios are the same, I have the angle in between them, so that would be a yes if they are. Is that? Yes. Divide them, 1.3s and 1.3s. Yep. So they both reduce to what fraction? 4/3, yeah. So 4 to 3 or 4/3 would be the scale factor. And so this is yes. We already know that it's side angle side because that's the one we were looking for. And our statement then would be triangle. If I say KJL, then it would have to be KMP, right? Or sorry, NMP. All right, this bottom one then. Do I have an angle in both triangles? Yes. Yeah, so this angle, reflexive property, right? It's in both. So let's go largest to smallest. So what's the largest side over here? What is that length right there? 25 compared to 15. That needs to equal 21 and 12, right? Does it? That's 1.6s and 21 over 12. I heard some no's. So this is 1.75 and this is 1.6s. So those are not the same. So this is a no. Although we had an angle in between two sides, sides ratio were not the same. Okay. So you're doing the same thing on your assignment. Are they similar? If they are, what reason? So if you have two angles, but this one's kind of set up to where you're like, oh, I'm only trying for side angle side here, right? There's no other way to get sides or other angles, right? The only way you'd have other angles is if you had parallel lines. The only way you'd have sides is if you had some other information like a bisector or a midpoint or something. Okay. Number two, which one are you trying to prove? Side, side, side. That's all the information you have, right? You don't have any angles. Okay. So that's what I'm saying. These tend to be a little easier because of the information that's presented. You kind of only have to really figure out one or two possibilities. Anyway, 5 parallel lines. You're going to find angles.
Are these only 3 rows, like for proofs? Are these only 3 rows?
Are these what?
Like these, will these be the only 3 rows for?
Yeah, those are the only ways to prove triangles similar.
Aren't they congruent? Aren't they similar to this?
If they are congruent, they are similar, yeah. Because you'd have, sides that have the same ratio, right, of 1, and you'd have at least 2 angles either way, right? So good point. If 2 triangles are congruent, they're also going to be similar, but the converse is not true. If they're similar, they're not always going to be congruent, right? Okay, there you go. Have a good time.
Thank you.